Hey everyone, welcome. Today, we're going to pop open the Coder's Toolbox and take a look at some of the most important programming languages out there. And I want you to think about each language not as some big, complicated puzzle, but as a tool. A very specific tool, designed for a very specific job. All right, let's get into it.
So, picture this. You've got this amazing idea for a new project. You're all fired up and ready to start building. But wait a minute. You hit your first major roadblock. Which programming language do you actually use? I mean, there are literally dozens of options out there. How in the world do you pick the right one?
Well, here's the secret. You have to stop asking which language is the best and start asking which language is the best for this job. It really is that simple. You wouldn't use a screwdriver to hammer in a nail, right? It's the exact same logic with coding.
To really understand this, we've got to go way back to the beginning. The very first major high-level languages were created as these super specialized tools for two totally different worlds, the world of science and the world of business.
Okay, first up in our toolbox is Fortran, and its name kind of gives the whole game away. It stands for Formula Translation. It was built from the ground up with one very specific task in mind. And what was that task? Well, it was all about solving these huge, complex scientific and engineering problems. We're talking physics calculations, weather forecasting, you name it. Anything with a ton of math, that was the world Fortran was designed to absolutely dominate.
And you know what? It was amazing at it. It made typing out complicated algebraic formulas feel totally natural, and it came loaded with built-in functions for all the heavy-lifting mathematical stuff. For a scientist back in the 1950s, this was a complete game changer, absolutely revolutionary.
But, okay, while the scientists were off crunching all those numbers, the business world had a completely different set of problems they needed to solve. So, developers built a completely different tool, COBOL, the Common Business-Oriented Language. Yeah, COBOL wasn't made for advanced calculus, it was made for commerce. Its whole purpose in life was to process massive, and I mean massive amounts of business data. Think payroll systems, bank account records, inventory, all the stuff that keeps big companies running. Its big selling point was readability. COBOL code reads almost like a normal English sentence. And that was super important because it meant huge teams of programmers could maintain these giant systems for like decades. Now, the flip side, it was super wordy. Writing it took forever because you had to spell everything out. So right here, it's crystal clear, isn't it? You've got two pioneering languages, and each one was the perfect tool for its specific job. They weren't even really competing with each other. They were just solving totally different problems for totally different people. But then, everything changed. A whole new world opened up, the internet. And this new, connected world needed a brand new kind of tool in the toolbox. And that tool was Java. It was designed specifically for the internet, built around this radical new idea: write once, run anywhere. The dream was that you could write your code just one time and it would just work on any computer out there. A Mac, a PC, you name it. So how'd they pull that off? Well, that was through this really clever thing called bytecode. See, instead of compiling your code for one specific type of computer, Java compiles it into this intermediate universal language. Then, a little program called the Java Virtual Machine on any device could translate that code on the fly. It's what let Java power everything from the first interactive websites to the software in your Blu-ray player. Even its creators called it a clean language. What they did was, they took the raw power of a language like C++, but they deliberately stripped out some of the most complex, error-prone parts. They were aiming for that sweet spot, you know? The perfect balance between power and simplicity. So that brings us to today. If Fortran was a powerful calculator and COBOL was a massive ledger book, the tool that modern developers reach for is something more like a Swiss Army knife. Super versatile, easy to use, and ready for pretty much anything you throw at it.
And that would be Python. Python was built from day one to be incredibly flexible. It lets you write code in different ways. You can write a simple top-to-bottom script, or you can build a really complex system with lots of interacting parts. It's this chameleon-like adaptability that makes it the go-to for so many developers today.
Why did it get so popular? Well, first off, it's totally free and open source, with this massive global community behind it. It's also famous for being easy to read and learn. But the real secret weapon? Its huge collection of libraries. These are like pre-built toolkits for almost any job imaginable. Need to do data science? There's a library for that. Want to build a website? There's a library for that too. That massive ecosystem is a huge part of its power. And hey, Remember how we said COBOL was wordy? This chart shows you exactly what we meant. The amount of code you have to write to get something done in Python is just a tiny fraction of what you needed in older languages like COBOL. And what that means is developers can build things way faster with way fewer mistakes.
Okay, so we've looked at some of the tools. Now let's switch gears. Let's put on our tech consultant hat. How do you actually make the right choice for your project? Well, there's a pretty good framework for that.
So first, before we even pick a language, let's just think about what makes any programming language good. Well, a good language should feel simple, it should feel natural for the kind of problem you're trying to solve, and needs to be efficient, encourage you to write clean, well-organized code, and most importantly, it has to be a great fit for the environment it's running in.
So, with that in mind, here's a quick 5-step check you can run. Step 1. What exactly are you building? Step 2. What does your team already know how to use? Sometimes the best tool is the one you already have. 3. How hard is this new language to learn? 4. What's the community and tool support like? And finally, step 5, how important is raw speed and performance for this specific project? Which you see brings us right back to where we started. The whole point of this. There is no single best programming language. There just isn't. The right language is and always will be the one that best solves your specific problem.
And that leaves us with one last big question to think about for the future. As AI gets better and better at actually writing the code for us, what becomes the most important human skill in all of this? Maybe it's less about the technical skill of writing the code and more about the wisdom of choosing the right tool for the job. Thanks for tuning in.